Hey everyone, thank you for joining us for today's Traxon EQ webinar on the key considerations in specifying media. My name is Erin Zabelski. I'm the marketing manager for Traxon North America, and I will be the moderator for the session. Presenting will be our very own Cy Eaton, Global Solutions Manager, and Doug MacDonald, Business Development Manager. And with that, I will turn it over to Cy and Doug.
Thank you, Erin, and thank you all for joining us today. We're really excited to change up our webinar program a little bit. We won't really be talking about products, not launching any new products today. This is going to be a bit more of a educational lunch and learn style session. So in that theme, let's have some learning objectives. So at the end of this session, you are going to understand how content considerations, media content considerations will impact your fixture selections and why you need to have some idea of what content you'll be displaying to properly specify and budget out a media lighting solution. You'll also understand how bright and what contrast levels you'll need to achieve in order to see in a variety of ambient lighting conditions, and also finally understand how pixel count, screen size, and viewing distance affect resolution and your decisions on what kind of content you'll be displaying. So with that, let's dive into, well, the content on content, starting with the why of media lighting. Why would you specify some sort of dynamic media lighting package for your next project? And we hope you do, because the various scales of product and control packages that are now available make this attainable at any sort of scale, both interior and exterior. And common reasons we see projects reaching for the media lighting portfolio is so they can highlight architecture as the overall form or a key feature, draw attention, transform environments, especially at night, creating some magical moments or responding to seasonal events, engage with occupants or passersby. Often that's in the form of a branding reinforcement to not just say this is a building, but this is a building owned by X company and please remember us. And then just simple, straightforward communication and information, sometimes in gestural, just broad brush cues. And sometimes all we want to do is entertain or make things pretty. And there's nothing wrong with that. Now, you might be thinking, well, gee, these are the standard waypoints of any architectural lighting design. We find that dynamic lighting, especially media lighting, takes all those traditional goals of architectural lighting design and offers a chance to just amplify everything. Not to mean make it louder or bolder, just gives you more and more choices and that allows the architectural lighting to achieve more of each of these goals. So to give you a sense of how that might work, let's go through a quick design charrette on a sample integrated media lighting project. So we're pulling this example from the San Mamés Stadium in Bilbao, Spain. And that is a stadium that is located near the seaside. So architecturally, they decided they wanted a nod to the seafaring culture of that region. So they took the cue of sails from sailing vessels, and really the entire monolith of this stadium is clad in these plexiglass sails and nicely softens the architecture a bit. And then that, of course, is a great architectural feature to light. And you could go just, there you go, concept form, light, and then you have this lovely green building. Maybe it changes color, it could be green, blue, white, whatever. But what if each of those sails was individually controlled as well? Or even better, what if each of those sails was individually lit by multiple points of light? So you could even make those sails almost flutter with light. And with all of those sails effectively turned into media pixels, and we'll get more into the concept of a pixel later, that stadium facade becomes a dynamic piece of media that you can run media and shows and effects across. And look at the difference from the static light on the left versus all of these effects that we're sampling in the video on the right. So with those core concepts established, I'm going to pass it over to Doug to talk about key techniques and considerations for the specification of your system.
Thank you, Sai. So I'm going to start out by just talking about some of the basic lighting techniques that we use in media and kind of go over these fairly quickly, but direct view is certainly the simplest, right? We're just putting fixtures out there for people to look at. They may be single pixel fixtures or multi-pixel fixtures. They may have diffuse lenses or they may have clear lenses. But basically, we are just creating an array of fixtures that people can observe. One note here, and I'll have sort of a key thought for each of these techniques, is that you need to balance the visibility of your installation with the possibility of discomfort glare, and sort of think about what is too bright and what might be too bright in certain conditions, but not in others. The next technique we wanted to talk about is cove lighting or niche lighting. You might think of this as an ambient technique, but as you can see here from some of these photos, it can actually be used also as a media technique with one or more pixels illuminating each of the individual boxed out sections of a facade or an interior, so that we can use these to display some sort of media content. And the big concern here is considering how you're going to isolate the light from one pixel from the light from the next pixel, and hopefully your architect has helped you think about this and come up with a plan for how we're going to illuminate it. Edge lighting is maybe the least common of these techniques, in part because it really only works in pretty dimly lit environments. But the idea is basically to take a clear substrate, whether that's maybe glass or acrylic, light it from one side, and then etch something into a portion of that object so that we have some contrast between the dimly lit clear object and the portion that we want to be really bright. It can be a really magical technique, something that is very unexpected if it's properly applied. And then finally, backlighting, maybe the next most common technique after direct view. What you can see here from the photos is that we can get a lot of different effects from backlighting. Sometimes we want to see the individual pixels. We have a pretty translucent surface that we're backlighting. Other times we have a more opaque surface, and what we really want to see is a blend of the light from all of the pixels behind. And then, this project on the right shows us that we can even create patterns in that surface and use those to just illuminate portions of it to create a really different impact. The big concern here is you really have to mock this up. A difference of as little as an inch in setback between where you want it and too close or too far away can completely change your effect. Can also show us that we have too much light or too little light for a given installation. So try and, when you mock it up, mimic the ambient conditions of the actual installation. And one more thing I want to talk about is just layering these techniques on top of each other. By having more than one layer of light that can interact with each other, we can go from having what feels like a pretty static display that is maybe feels like just a screen, to having something that is really alive and has some depth to it, where we can fade back and forth between different effects and really create a show that feels like more than just a little bit of light. With those techniques introduced, we wanted to talk about sort of the key factors to consider. So a lot of these are going to look like factors that you'd consider in any architectural lighting installation. Is this a focus? Is this the key feature we want people to be paying attention to? Is it just an ambient addition to our installation? How big is the screen, and where is the audience in relation to that screen? And when is the audience going to be viewing it? Is it daytime? Is it nighttime only? Is the facade north facing or south facing if it's daytime? Those will all have big impacts. Resolution, and Sai will talk about this in a lot of detail later. Control. How is it going to operate? Is it just going to play back a predetermined set of content, or is it going to have some reaction to environmental considerations or even interaction with the audience? And then the big concerns we always have with regard to logistics. Is it outdoors? Is it indoors? What's the temperature? What's the humidity? And are we going to get water directly on it? Is it coastal? Does it have vibration concerns? Where's power coming from? Where can we put our control equipment? How are we going to access these when we need to maintain them over time? You've got potentially a lot more fixtures in a media installation than you might have in a standard installation, so that access piece is even more key than it might be in another installation. The next big concern is how much light do you need? If we were talking about an illumination application, we'd go to our IES handbook and find, we need maybe somewhere between 3 and 50 foot candles, depending on where this is going, what the other lighting considerations are in the area, whether we're trying to read something or it's just illuminating a building for security or visibility purposes. We'd also go to our code book and say, how much power do I have? And if it was a colored lighting application, we would also maybe have to consider our V lambda curve, which, just as a reminder for everybody, tells us that we get a lot more credit for radiant energy in the middle of the spectrum, in that green and blue and yellow portion, than we do for energy at the ends of the spectrum in the red and blue areas. And therefore, if we're really focused on those areas with our content, maybe we have a customer whose logo is blue, we may need more light than we would if it was a white light or a green application. This, though, is really a luminance or an exitance application where we're looking at fixtures. You may need to take the lumens off the spec sheet for the fixture and figure out how many peak candela you're getting off of it if that's not reported on your spec sheet. This equation in the middle helps us do that. But we also need to consider, so when we consider exitance, we need to consider, where is this going? If it's in a room that has no daylight, we might not need a whole lot of light, 80 to 100 candelas per meter squared. But somebody might say, oh, it's daylight view. Well, is this indirect daylight, or is it a display that's going to be indirect sunlight? Or, is it interior and we're getting direct sunlight through a window, or is it exterior and we need to be able to read it from far away? The span can be somewhere between about 10 to 1 for indirect daylight to direct daylight. And really, when we go to some of those outdoor applications, it can be as much as 40 or even 60 to 1. So understanding the ambient lighting concerns is really key to figuring out whether we're going to be able to see this. But it's also important to think through contrast. If you're watching something on television, you probably want a contrast ratio of about 300 to 1 to be able to get really good image quality. But printing on paper is maybe 100 to 1. And when we think about accent lighting, we usually use a ratio of about 10 to 1. So again, think through, is this a feature we want to really be able to pick out all the detail? We need really high contrast ratios? Or is this an accent? We really need a low contrast ratio just to be able to add a little bit of animation and interest in our space. Also important to think through is, are we looking at direct view pixels where we can actually see the LED, or are we looking at something diffused? Because if we're looking at direct view pixels, we get a much higher contrast ratio by using the meters squared of just that individual LED chip than we do when we look at a full display and we're averaging the amount of light coming out of all of those pixels across a big area. And also, if we're using a diffusion material, we're balancing the ambient light bouncing off of that diffusion material versus the light we're creating coming through that material. And so we get much less contrast when we are using a diffused solution than we do when we're using a direct view solution. So with that, I'll hand it back off to Cy to talk a little bit about pixels and resolution.
Thank you, Doug. Yes, since you're specifically checking a direct view versus diffused pixel in that last slide, it's a good time to say, define what is a pixel in terms of media lighting. The word pixel is a portmanteau for picture element. So a the pixel, and that's every individually controllable unit, be it a square, circle, a rectangle, just the individually controllable unit of intensity and color that makes up an overall media image. So I use our pixel board line as a quick reference point, where on the left you have our 16 pixel board, thus named because there's a 4x4 grid for a total of 16 individual RGB nodes that are each individually controlled. So 16 pixels, just like we have the 64 pixel board in the center, but then on the right, you'll see there's still 16 clusters of RGB nodes, but we're calling it the 1 pixel board. And that's because the entire board is controlled together. So that board is 1 pixel, even though you can even see individual clusters. So that understanding pixels, then we go to pixel pitch, because it's how far apart or how closely together those pixels are spaced on center gives you your overall resolution. So the closer together the pixels, you're higher the resolution. So on the right of this stadium facade, you'll see an actual video screen. And that probably has a pixel pitch of about ½ an inch, left to right, top to bottom. And that's pretty common for a video screen that's meant to be viewed at 10 to 15 meters away. It's also very high intensity because you have so many nodes and meant to be viewed from relatively far away with some detail. Then the overall facade, that has fewer pixels, but its resolution is interestingly from left to right about 1 inch for this MediaTube product. But then the media products are spaced top to bottom about 20 inches apart. So you have a 1 inch by 20 inch pixel pitch to make a resolution that still from a distance gives you very good clarity of this image of an eyeball blinking on the facade, which I think is very cool. So to go a bit further into what different resolutions mean for your content and why you need to consider content when deciding on your fixture solutions and your resolution, we're going to look at a particular project mock-up that we were doing for a huge 10-foot by 30-foot light box at the main porte cochere for a hotel resort casino that we were helping relight. And you can see these big doors swung open and there was just some fluorescent backlight that had aged out and they wanted to replace it and update it. So we said, well, we could just flood this with light and maybe make that color change. And they said, yeah, but could it do more? And that's when we started saying, well, yeah, we could put some media lighting in there. But what we specifically put there or recommend will depend on what kind of effect you want. So I said, well, what if we had some champagne bubbles bubbling up this, because it's narrow and tall, it looks kind of like a champagne flute. And so we said, oh yeah, and actually 1 inch pixel, that's going to be really obvious, but even at a 1 foot pixel pitch, you have a bit of a sense of what's going on, especially when that's running as video. You'll see all these little bubbles floating up to the top. And I said, well, what if I wanted to put messages on this? And so we mocked that up as well. And the 1 inch pixel pitch, you could definitely say, welcome so-and-so, we're happy to have you. But at 4 inches, that pretty quickly started to fall apart, and 1 foot was definitely a no-go. And we even briefly discussed what if we completely redid the diffusion so there could be more crisp pixels. And in fact, what we find by going with hard edge pixels, either isolated or side by side like this, sometimes the image gets less clear, not more clear, because our eye is compensating for some of that blur, and we're able to resolve the picture better visually, because our visual system is a fascinating thing. So diffuse was good. Champagne bubbles, pretty easy. Text would have been much harder to achieve on this particular application, but let's talk a little bit more about text, when to use it and when you might not want to use it, because typically if you talk to AV people and they're talking about large projectors or video screens, they're going to say they're really worried. They just want to make sure the text doesn't get too small, doesn't look like fine print, and you want it legible. So then they just take whatever the viewing distance is and divide by 500. So that, to do the math quickly, at 100 meters away, that's going to mean a 0.2 meters or 200 millimeter text height is your minimum text height. That's 8 inches. Sure, seems reasonable. Now, with media light, we're actually much more worried about the text resolution. And so rule of thumb is 10 lines of pixels is enough to resolve text. Otherwise, you're going to get like what we saw here, the text in this approximately 1 foot tall block of text just doesn't really read. So 10 lines of text. If you really need text and you don't have that many pixels, you can get down to 5 or 7, but 10 is a great rule of thumb. So that means actually much easier math if you're going to be 100 meters away with 1 inch pixel pitch, 1 inch times 10, 10 inches is going to be your maximum possible render, and that's larger than 8, so we know we'll be able to see it. 4-inch pixel pitch means you'll want at minimum a 40-inch block of text, so 3.5 feet. If you have 1 foot pixel pitch, you'll need a 10-foot tall text. Now, that's pretty big. And that gets us to our next consideration, and that is that if you start putting text on a media lighting installation, because we are not video screens out in public are typically considered signage, and they have special regulations, considerations, restrictions. Media lighting is not innately considered signage. It's just architectural accentuator. But as soon as you start scrolling text or placing text up on that building, it's possibly going to get regulated as signage. You might find yourself in a whole new soup. So just consider all of that picture before you start using your media screens as text banners, although it can be a fun application in some appropriate cases. Then one more concept around resolution, and I've touched on it a little bit, and that is partial resolution. So we're going to use the Colorado Avalanche NHL team as our example for this. This is their logo. And what if we wanted to render this on a building, but we didn't want to have just a block of media lighting or a whole screen that took up the whole video screen that took up the entire facade? So what if we broke this up into this little spaced out strips of media light? Well, if you didn't know what that logo was, you'd probably be looking at that, and that's just a bunch of weird stripes of blue and red. But what we can do by making this dynamic, we can get a reverse zoetrope effect. And by panning that logo across your zoetrope screen and then playing with the timing a bit, the eye starts filling in the gaps, and you get that effect without being overbearing with your media. And actually, we did this at the Denver Stadium for the Avalanche, and there's the end product there. Nicely integrated media lighting on the architectural facade instead of just a block of a video screen taking over that entire space. So with all of those considerations of resolution and content and what types of resolution, what types of content work together, that brings us to the end of the hardware specification resolution considerations. And now we want to touch on, there's really 3 elements that make up a media lighting installation. Hardware specification was our focus today, but there's also controls and then the programming content, and we're going to touch on those very briefly to wrap it up, starting with Doug on controls.
Thanks, Si. I want to start just by briefly talking about the purpose of our lighting control system. Typically, when we're speccing lighting controls, we're probably interested most in code compliance, energy management, the ability to turn lights on and off at the levels we want them at. But a media lighting control system is really almost more like a content management system that you might have for audiovisual or digital signage. We want to maintain, modify, and in some cases even actively generate content for our media lighting. DMX is going to be our primary schema for thinking about controlling color. Just as a reminder, DMX gives us control over 512 channels and at 256 individual steps per channel. There might be some cases, though, where your content isn't happy with just 256 steps and you need more. And so in that case, we might go from 8-bit control to 16-bit control. And now instead of 256 or 512 channels, we're only going to have 256 channels, but we'll have much finer control over those channels. Also note that some fixtures do maintain some smoothing, so they're going to give you a greater than 8-bit fade, maybe a 12 or 14 or 16-bit fade with just an 8-bit input. That can be a pro or a con. If you've ever tried to watch a high-speed video, maybe sports or an action movie on a TV with the smoothing algorithms turned on, it probably drove you crazy and you figured out how to turn it off real quick. But most TVs now have that built in, and if you watch it, you'll see there's pros and cons to turning that on and off. But also, a lot of our fixtures now are no longer just RGB. We've added a white chip for RGBW, or in some cases, some other color chips. And at Traxon, we decided we needed to be able to still make use of that white chip when we were driving with a video signal, which is only RGB. And so we've created a plus white mode that allows you to use that white emitter when you're feeding RGB into the fixture, either by adding it to the RGB when we desaturate, or by replacing the RGB when we desaturate. And we call those HO, high output, or HE, high efficiency mode. So those can be just a little benefit to add some more capability and brightness into your system. Another thing to think about is Ethernet transport. As I said, 512 channels on a wire with DMX. That's not a whole lot when we get into media systems that might have thousands or tens of thousands, or in some cases, hundreds of thousands of pixels. And so what we've done is allowed ourselves to put that DMX signal on an Ethernet wire, which allows us to put hundreds or thousands of times as much information onto one wire. But basically, it's still just DMX data with the addition of a portion that tells us what universe we're talking to. So it's standard Ethernet data. Contractors know how to run it. It's cheap and effective and easy, and greatly increases the capability of our systems. Pixel mapping is a technique that we can use to allow ourselves to pre-visualize our content on our application. We make a 3D model of what our media lighting is going to look like, and then we apply our content to it. This greatly reduces programming time in the field. We can program in our nice air-conditioned offices where we're comfortable and we have more screens and more capabilities, and not on a dusty job site where it might be hot or wet or otherwise uncomfortable to work. A great tool for us. One thing I'll note is that it doesn't replace the need to preview our content on the actual installation. Blue on your monitor might not be the same as the blue that you get on your actual installation, or there might be more ambient light, and so you get less contrast in the field. You still want to preview all of that in situ. This is just a way to reduce the amount of time you have to spend doing that in the field. That'll hand it back over to Cy to talk about content.
Yes, content, the very important and most commonly forgotten element of a media lighting application. The reason you want to think about this early on is because it's going to affect who your team is and how much time you'll want to factor in for the integration and programming process. So we break dynamic lighting typically out into 3 tiers of control complexity. We have the active, reactive, and interactive. Active is dynamic scenes, but they're pre-baked scenes, and they're either just run through in a timeline sequence or based on open, close, cleaning mode, and special event. That's it. Reactive is also a sequence of pre-programmed looks and scenes, but there's at least some outside triggers are able to come in and tweak things slightly based on other indicators, maybe a particular time of day, special events for holidays and other times of year, whether the local team won or lost. And then you get into interactive, and that's where you have multiple inputs, user inputs, building inputs, environmental inputs, and then run through magic, the secret sauces, and you get dynamically designed content. Thank you. So then you get truly dynamically created content in the space that's responding to the space. So that is, in my opinion, that's always the dream, and that's always very cool as an end installation, but it does take a lot of talent to get that to install and succeed correctly. So there's some capabilities that are baked into our fixtures and our control software and to the Traxon team that we can help you with for certainly a basic active and some reactive systems. Once you get to more complex reactive systems and especially interactive systems, or if you have specialty content, you need to think about who's generating that content, even if it's pre-programmed. And either the Traxon team can coordinate with you directly, or we can recommend expert third parties that specialize in this sort of design and programming and integration to collaborate with. So with that, we want to open it up for questions. Like I said, we touched briefly on content and controls today, but really today's theme is about resolution and hardware considerations for the specification process. So we welcome questions on that themes.
I will start with one that's a little bit on the lighter side, a little bit of a joke, I think, but worthy. Thank you for demonstrating the use of logos with resolution. Any predictions on the Stanley Cup Finals?
Living in Denver, I'm hopeful for my Colorado Avalanche, but
Your Western
anything could happen.
All right, we'll move on to the next one. And this is actually, I think, a great question. Very simple and straightforward, but why is it called media lighting?
We're trying to make a distinction between dynamic lighting, media, because dynamic lighting could just be some color changing wash fixtures. Media lighting, it takes a bit of a cue from video input is one of the possible control inputs. You could put a video file through our control system and render that into a dynamic scene, but we're really not a video screen. For various reasons, we serve a different role in the architectural and media integration sphere. So media lighting.
Great. When should I choose direct view pixels instead of diffused?
It's a good question. I think it has a lot to do with some of those ambient light concerns we talked about. I would say clear lens direct view fixtures are most commonly used when we do want to have an outdoor daytime visible screen, and most commonly when it's a little bit further away from the viewer. That direct glare of looking right at the lens can be a lot to take if our screen is right up next to people, and much easier to look at if it's 60 stories up on the crown of a building. Somewhere in between, there's probably a crossover point at which it becomes more acceptable to the eye.
The other trade-off sometimes, especially for these medium to long view installations, is whether you want to be able to see that effect from very far away from one specific corridor or vantage point, or if you want it to be seen from pretty far away from a very wide angle. A wider angle, typically you'll go with the diffuse lens option, and direct view is not going to be focused, but it's going to be better for viewing from kind of a narrower set of viewing angles. And this just comes back to when you're ready to move forward and finalize some of these things, we can both help you a little bit, but also a mock-up is the best way to know for sure you're getting the effect you want. Oh, and I did get a message from one of our programmer and installers on staff, and he wanted me to remind folks when selecting content, in addition to resolution and matching the fixture to the architecture, you really want to situationally match the content to the architecture and the environment. Make sure that your content is appropriate. Now, again, we're not talking about whether it's PG-13 versus R-rated. We're talking about maybe it would be in poor taste to put flame content up on a building facade, because that used to be one of our standard test patterns. And then there have been a couple of real tragic fires, and that's just, people don't want to see that even when testing, even if it's not part of the normal program. And like I said, signage is another question. If you're going to put text up there, make sure it's going to be okay.
Thanks, Sai. We did get one more question come in. It says, what is the range of price per foot for these types of projects?
Yes, the final piece of scaling the project, because you want to think about all these factors so you don't buy too many pixels, too much brightness, because those do, resolution and brightness certainly drive the cost up. So then budget is the third. So we can really help you scale your project both to the solution, to the scale of the project, and the scale of the project's budget, because we can tweak both with fixture selection and resolution and brightness to bring it all in for a landing. And Doug, feel free to add on to that.
I would just say, I think it's really hard to answer that question without a little bit more detail. We've certainly done media projects that are as low cost as, $8 or $10 a pixel installed to the owner, and as high as, a couple $100 a pixel installed to the owner. And really that has a lot to do with, the size and the brightness and the environmental concerns around those pixels. as well as any diffusion material, right? I mean, some of that diffusion material can be as much as $100 or more a square foot. So, if you go very high end on that, you can get a very high cost for your installations. So, bring us specifics about a project and what you're trying to accomplish and where it is, and your Traxon business development managers are all well suited to help you select the right product for your application.
Would these same content considerations also come into play if using high resolution screens?
I think they do, yes. But with a high res screen, you typically have kind of a baked in range of brightness, a baked in range of pixel pitch. And so maybe you don't have to think about it as much because some of those decisions are just made for you by the fact that you have selected a high resolution screen.
Whereas with a media lighting application, you might want to, even before you're mocking up the content images, examples that we were showing earlier, I actually did produce to scale, and that I figured out what the size of the box was, what the pitch resolution was, and just downscaled some reference images to that exact pixel resolution and to see what it would look like. So you can do that in scale for your next project and see what various media solutions look like.
Can Traxon help with understanding local code compliance for media applications?
I'm going to say yes and no. We're not going to represent as the code authority on a project, but certainly, especially when you get into cross-region international projects, we can help make sure that that all of the general regulations and code considerations are being taken into account. You don't have to become an expert on a completely different state or a completely different country or region. We'll definitely help you navigate that.
Great. So the last question is, are these products harder to install?
There's going to be a little more wiring. There's going to be a few additional considerations. We have a range of product solutions. Some are geared to be a little less flexible in their application and integration, but very quick plug and play to install. And others that take a little more finesse, maybe a little more specialty care in installing, but gives you a ton of flexibility in the finesse of integrating into the architecture. So sometimes it's harder to install, but it doesn't have to be, and we can help you make those decisions based on the team you have on board.
Well, as I said, that was the last question to come in. So we thank you all so much for attending today. We hope this was helpful. If you think of questions after the fact, don't hesitate to reach out. Thank you so much, and we look forward to seeing you at our next webinar.